Very well. So what we learned so far? We learned that, hey, we have statistics. Okay, what is statistics? It's a branch of math. We keep repeating this, and it involves some steps. The first step that we learned, collect data. You need to make sure our collection of data is unbiased and it is definitely random. We learned that our data can be numerical or quantitative or categorical or qualitative. In the next step, we're interested in visualizing the data. So this is step 2. Visualizing the data. In step 2, chapter 2, we're going to talk about how to visualize the data. The very first method in visualizing the data is using frequency table. Frequency table actually helps us to gather the data and write them in compact and nice format. It helps to present the data in a compact form, which is actually a table. Then we're going to talk about other methods of visualizing the data using our calculator software. We can use histogram, bar graph, pie chart, and so on to visualize the data better and actually analyze the behavior of our data. But the very first one is the frequency table. When it comes to a frequency table, we need some information. So information needed for this table. First of all, you need to construct classes or beans. Classes or beans. You need the frequency or count for each class. Frequency or count for each class. We need to find the midpoint for each class. The midpoint for each class actually has a nice formula. We're going to talk about the formula later when we form our table. So the midpoint for each class. We need relative frequency. And we need cumulative frequency as well. Perfect. So frequency table includes all of these information. Let us begin. Let us go over one example, and for that example, our goal is to actually form a frequency table. So we have an example, constructing a frequency distribution for a data set. The data set lists the prices of 30 portable global positioning system or GPS navigators. Question says, construct a frequency distribution with 7 classes. So in this example, the number of classes are given to us. They already collected the data, and we trust that the data is correct. So these are the numbers that we have. Our job, our goal is to construct a frequency table that has 7 classes. Okay, let's go to the board. And start constructing our frequency table. This is the very first method of visualizing the data without using a software, without using a calculator, just using pencil and paper. Here we go. Example of GPS. Okay, awesome. So our goal is to construct a frequency table. We want to construct a frequency table. Okay, it is a table, and we know that we need classes or beams. How many classes? The question says 7 classes. The question asks for 7 classes. Okay, it means that we're going to have 7 rows. Let's build this step by step, column by column. Classes or beams. For sure, we know we have 7 of them. So this is our first class, second class, third class, fourth class, fifth, sixth, and seventh class. The next one is going to be frequency or the count. Okay, so how do we build classes? Where do we start? Note. To build classes or beams, we start by the smallest number in the collection. Smallest number in the collection. So what is the smallest number in the collection? What do you see as the smallest number in our collection?
65.
65. Thank you very much. So the minimum value in your collection is 65. We also need the maximum value. Now find the maximum value. What is the maximum value in the collection?
340.
The maximum? Waiting for the class. What is the maximum number?
340.
340. Thank you very much. 340. By using the minimum and the maximum, we're going to construct something that we call the class width. Now, find the class width. The class width is the maximum minus minimum divided by the number of classes. Maximum minus minimum divided by the number of classes. So this is our very first formula that we learned in chapter 2. Class width. What is your class width? You have your maximum, you have your minimum, you have your class width. What is the class number? What is your class width? It is equal to 340 minus 65 divided by 7 classes. Approximately, what do you have?
39.3.
39.3. We don't like decimals. When you are constructing class width, we don't want to have decimals. You can either round it up or you can round it down. Both of them are fine. So I'm going to round this up and I'm going to use 40 as class width. Well, what is the next step? We're going to construct our first class. Our first class starts by writing the minimum value in your collection, 65. This is your very first class, and the start point is 65. 65 plus 40, 65 plus 40 actually forms your second class, which is 105. Your next class is 105 plus 40, which is 145. I'm just writing the very first number in each class. Of course, you can guess what is the next number in your class. Okay. After 145, what do we have? We have 185. Then we have 225. The next class starts 265, and the last class starts at 305. Okay. In statistics, we don't have overlap between classes. There is no overlap between two classes. This is 65, 65, 66, 67, 68, 69, 70, 75, 76, 78, 80, 81, 82, 83, 90. So it includes all of those numbers and it stops at 104. 104. Again, this is your very first class. What is the frequency of first class? How many numbers are in the first class? Let's take a look at our collection.
6.
Very good. We have 90 here. We have 85 here. We have 65. What else do we have? We have 80 here. And then what is the next number? We have 90 here. So in total, you have 6 numbers between 65 and 104 in this collection. So you write frequency equals to 6. The first class, the beginning number or the lower limit of your first class is 65. This class stops at 104. Why is that? Because you cannot have overlap between 2 classes. So we have to stop 1 unit before the beginning of next class. So this is our first class, and the frequency or the count of the numbers that are repeated between these 2 is 6. Next class, it starts at 105 and it stops at 1 unit before 145, which is 144. What is the frequency? Let us take a look at our data. We're counting all of numbers between 105 and 144. Okay, 128. And then we have, let me see, 105. What else do we have? 120. We have 130. Of course, we have 110. We have 112. And that's it. So the frequency or count is 6. Sorry, this is 9. You have 9 numbers between 105 and 144. The frequency or count of the second class is 9. So what is the upper limit of the third class? It is 184. What's the upper limit for the next class? It's 224. What's the upper limit for the next class? Is 264. And here you have 304 and the maximum value. So the difference between each of upper limits is 40. 144 minus 104 is 40. The class rate. The difference between these 2 is 40. The difference between these 2 is 40. The difference between these 2 is 40. So the difference between these 2 must be 40. Or if you add 40 to 304, you get 344. So by counting the numbers in each class, we have 6, 4, 2, 1, and 2. Now I expect you to ask, what if I add all of these frequencies? What is it equal to? It is equal to, so if I add them all together, add them all it is equal to 30. What is 30? 30 is the number of data in your collection. Okay, our next step is to find a midpoint for each class. So note that another formula, the second formula for chapter 2 is the midpoint. To find the midpoint for each class, we add the lower limit of the class by the upper limit of the class and divide it by 2. Add the lower limit by the upper limit of the class and divide by 2. So the second formula for you, the midpoint, is equal to lower limit plus upper limit divide by 2. Okay, perfect. So let's erase this count. Need a little bit more space. Midpoint. Why do we need midpoint? Midpoint is a good representative for each class. That's why we construct and form midpoints. So we have 65 plus 104 divided by 2, which is 84.5. Then we add 105 by 144 divided by 2. Then we add 145 plus 184 divided by 2. Then we add the lower limit and upper limit, 185 plus 224 divided by 2. 225 plus 264 divided by 2. Then we have 265 plus 304 divided by 2. And we add 305, the lower limit, and the upper limit, 344 divided by 2. To find the midpoint for each class, again, midpoints are great representative for each class. So step by step, we're actually constructing our frequency table. Calculate the rest of it. So here we have 124.5. Then our next representative, 164.5. Remember that the difference between each of these is equal to 40. Then the next representative, 204.5. Then next one is 244.5. Then 284.5. And finally, you have 324.5. Midpoints or representative for each class. Our next stop is actually find the relative frequency. Another formula for you. Note to find the relative frequency, we divide each class frequency by the sum of all frequencies. So relative frequency or sub f is equal to frequency of the class divided by the sum of all frequencies. The third formula for you in this class. So let us calculate the relative frequency for each class, or sub f of the first class. What's the frequency of the first class? It is 6. It's divided by the sum of all frequencies, which is 30. 6 divided by 30. This is approximately exactly 20%. Then you have the relative frequency for the second class, 9 divided by 30. Then 6 divided by 30. Then 4 divided by 30. Then 2 divided by 30. Then 1 divided by 30. Then 2 divided by 30. That's how we find the relative frequency for each class. Why do we need relative frequency? Eventually, we're going to use this information to construct relative frequency histogram. So as we continue the calculation, we see that, okay, we have 30% or 0.3, then we have 20%, then we have 13%, 0.13, then we have 7%. The next relative frequency is 3%, and the next one is the same as this, which is 0.07. Relative frequency. And the last column is cumulative frequency. So let us write this right down here. Cumulative frequency is very easy. We just add the frequency of classes together as we go along. Cumulative frequency. So the cumulative frequency for the first class is the same as frequency of that class. You copy down 6. The cumulative frequency for the second class is the sum of these two frequencies, 6 plus 9. 15. The cumulative frequency for the third class is 6 plus 9 plus 6, which is 21. The cumulative frequency for the fourth class is the sum of all of these previous frequencies along with the frequency of the fourth class. So it's going to be, if you want to write it down in simpler form, 21 plus 4, or 24. The cumulative frequency for this class is 25 plus 2, which is 27. Then 27 plus 1, which is 28. 28 plus 2 is 30, which is equal to the sum of all frequencies in your assets. Must be the same as the sum of all frequencies.